Next is the performance and the real time, how it is, how it is. In coming to the performance, now let's address the very common thing, performance and time real time controller. You may hear people say microprocessor is fast and microcontroller is slow. That is not technically correct. Performance depends on the processor architecture, processor architecture and number of cores, clock frequency, memory systems, hardware, accelerators, and the workload. Based on that only we can performance will be depend. But these are many people think like microprocessor is fast, microcontroller is slow, but that is not technically correct. Okay, the because is the performance is depend on the microprocessor architecture, number of cores, clock frequency, memory systems, hardware accelerators, and the workload of the microcontroller or microprocessor. Based on that, performance will be vary. The more important question is embedded system is often what type of workload are we trying to solve. Then coming to the real time example, uh, imagine vehicle sensor detecting an important event. Okay, the ECU needs to read the sensor, process the information, and control an actuator within the predictable time. For these applications, deterministic and the predictable response can be more important than simply having the maximum computing power. Then this is the real-time control. For example, if you take the sensor will give the input to the microcontroller will decision and it will take the action. For this controller, here the workload is like here take the data from the other external devices from sensor and take the decision and doing the what I have to do the next step. It took the decision and do the respective operations. Okay. Here the controlling the system deterministic and response can be matter more than the peak of the computer performance. Okay, this is the real-time controller. Then coming to the operating systems, bare metal, RTOS, full OS, okay, different. Let's look at the software. Microcontroller commonly run bare metal firmware or RTOS. Example include free RTOS and AutoSAR OS. So difference are there. And choices depend on the timing, safety, complexity, and resources. Okay, this is a microcontroller. It is there. And coming to the microprocessor and system on chip, it is a microprocessor and system on chip based systems commonly having the enough resource to run the full operating systems such as Linux, Windows, and Android are commonly suitable systems. More resource support richer application and interfaces. But important things is, but this is not a strict rule. The modern microcontrollers can run sophisticated operating systems and modern process can also run lightweight software. Okay,